The next item is to derive the Bessel equation. So it's just like going around. So it's write down the generating function of this expansion, and we show that by series solution, so that this satisfies the Bessel equation. But again, we can also use the same generating function and take derivative and derive these two recurrence formula. And the next step actually we can do is to use the two recurrence formula to derive the Bessel equation. So that is like going the other direction, which you can do, and it's not too difficult. And if you know how to need some practice, but there are multiple ways to do it. Some are more difficult than others. So your textbook has one way to do it, and it used one of these relationships, 14.10 to 14.12, to do that. It's one way to do that, and but yeah, different way. And then it's for general order, so we can actually rewrite this relationship to a general order using nu, and then we can also use a general symbol for the Bessel function, not just J, because other Bessel function like the Neumann function, and later on we define the Hankel's function, just linear combination of Bessel function and the Neumann function. So they all satisfy the same recurrence formula, but not the modified Bessel function. They satisfy slightly different recurrence formula. But anyway, for all those Bessel functions that satisfy these two, we can write it like so z to the -1. Nu is the order. So plus z nu plus 1 equals to 2 for x z to the nu. Okay, so that's the first one. And then z to the nu -1 minus z to the nu plus 1 equals to 2 z nu pi. That's this one. And we want to derive the want to show that the z sub nu satisfy the Bessel equation, and the Bessel equation is the first equation in this chapter. So it's change it to z. So the equation we want to show that z satisfy is we want to show that x squared z nu double pi plus x z nu pi plus x squared minus nu squared z nu equals to 0. Okay, and we can do that. Try to use this to divide. I mean, show that this two will give you this one. And the idea is, I mean, again, there's multiple ways. I actually did it different way in one of my solutions in the homework problem, not this set or the next set. A little bit later when we talk about maybe the Hankel function or something like that. But there can be better ways. Let's see if I can remember. Right. The more straightforward one is because there's a double derivative, and the second formula has this already have a derivative. So to get a double derivative, all you need to do is just take one more derivative of this relation, right? And so this is z nu divided by this divided by 2 is z nu. So you take another derivative, it gives you C nu pi. So C nu double pi will be like x squared over 2 C nu minus 1 pi minus C nu plus 1 pi. So that would be this one. It's okay. You can follow. Right? So this is coming from this one. So that's the first term, and the second term is you can use it directly now because this is exactly this one. So x over 2 C nu minus 1 minus C nu plus 1, and the rest we'll just keep it like it first and see how we deal with it. So that this becomes that, or you can say this equals to that. We can say this equals to that. Okay. And now the one more thing to do is now these are just single derivative, right? Single derivative, you can use this again, but it's not of the same order. This is C nu, this is C nu minus 1. So we need to shift it for each term. For each term, we need to shift the order. This equals to x over 2. Now you have two terms. Each one has two terms. So for this one, nu becomes nu minus 1. So it becomes, first you divide it by 2, another factor of 2, so a factor of 4. Right, and then each one is shifted. So for this one, nu becomes nu minus 1, this becomes nu minus 2. And the second one, nu is nu minus 1, nu minus 1 plus 1 is just nu. Okay, so that's the first one, this one. And then apply the same relation to the second one, the minus this. Now you shift the nu becomes nu plus 1. So this becomes nu plus 1, and minus 1 becomes just nu. And then the second one is nu plus 1 plus 1, nu plus 2. So that's this term becomes this one. Okay, and that looks getting even worse because now you have nu. Instead of just nu plus 1, you got nu plus 2 and nu minus 2. We'll see if we can simplify further. For this one, we'll just keep it like this, see what we need later. And just copy it first. All right, and the first thing you can do is identify that you have the x squared term here, and then there's an x squared term here. So you can combine this term to basically move this one, x squared times z mu, inside the bracket. So basically cancel that. Cancel that and move this inside. Right, and this is x squared z nu. And this is x squared divided by 4. So you need to, in the bracket, you need to plus 4 z nu. 4 z nu. Right? You see that? So just move this inside, so plus 4 z nu. But you already have 2 minus 2 z nu, right? And in that case, you can use that to cancel that. Basically, this plus 4 z nu, the effect is changing the sign of these two terms. Comes plus, and then you get rid of this one. And I'm just saying some writing. Instead of keep writing equation by equation, I just cancel this and move this inside and change the sign of the two terms. All right, so all right, and now we can see what we can do with this two. Because now after we change sign, the sign relation is like this one. And then we see that this is also the order of the two terms is different by 2, right? The difference is 2, just like here. But it's not the same this is new minus 1, new plus 1. This is new minus 2 plus, and then new. But then it's just like you shift it by 1. So if you apply the first relation, and you can see that this should be 2 over x to the z. This new becomes new minus 1, right? If new is new minus 1, this new change this new to new minus 1. This becomes new minus 2. This becomes new, which is exactly this one, right? Can you see that? I'm just talking because I don't want to keep writing equations. Can you see that? Right? So you can apply this one, and likewise for this one. This becomes c plus 1. This new becomes new plus 1, right? And this becomes new. This becomes new plus 2, right? So this becomes 2 over x times z, the new plus 1. Okay, so now I can write another equation. So each of these, the group it, these two terms give you a single relation. And both of these give you 2 over x. So you can take the 2 over x out. And the first one gives you z nu minus 1. The second one gives you z nu plus 1. Right. And then the rest is just write it out because you don't want to get too far away and get confused. And only one term survives, and nu squared z nu. Okay, and now the what? Yeah, this one?
That's 1 minus what happens? 1 minus the left.
One, which one has x squared? This one?
1 minus. I know that equation.
It's changed it. So this becomes that. This I use this. This becomes that. This I just copy this that. What is? Is
that a 1 minus or is that just
this one?
the one right? Just the symbol.
Oh, this is a symbol for to ask you to prove. This is a mathematical symbol, logical symbol. You haven't seen that before? To ask you to prove. I mean, we want to prove this. Okay, this is a symbol. Look up the math symbol, Wikipedia. Logic. I don't know all of them, but I just know enough because of the previous math classes. It's not one sometimes I assume you saw this before in your maybe other math classes. So maybe not everyone's just taught the same way. Right? Okay, so all these are fine, right? So now finally what we get is first of all we can simplify this. This is 2 over x. This x squared over 4. So simplify that is x over 2. Right. And now what do we have? Did I miss the relationship? I missed I missed. Sorry. When I copy it, when I divide, did I miss the n? There should be an n here. I don't have the n, so that becomes new. Yeah. So that's why it's not the same. So now again we need to now we need to retrace it. So the originally this is this becomes this using that and then change that, this becomes the new. So you have, I divided the x over 2. Actually, I need to divide the new also. And so this is actually c new minus 1, right? Or multiply by not divide. I need to divide this 2 and then get to this one. So this is new minus 1. The new minus 1. This new plus 1. The new plus 1. Okay, so that's more like it. Now the idea is you have x over 2 on both sides, and you have c minus 1 term, and but this minus 1, this is plus 1, and then you have c plus 1 is plus 1, this is minus 1. So you can cancel the whole thing. Cancel this whole thing with this just this minus 1 and plus 1 term. Okay. Now this is you can, there's a new, you can take that out. This is a common new out, and this is becomes c minus new plus c plus new, which is exactly this one, and give you 2 new over x. So you first take the new out, and the rest is 2 new over x. 2 new over x multiplied new x over 2 becomes new square. So this is new square, c new. And then you have minus new square c new. So that exactly c. Okay. All right, so sometimes it's just need to be a little careful when copying equation. All right. So that is how, I mean, at least one way to show that the recurrence formula will show that this function satisfies the Bessel equation. Okay, and this is for arbitrary order. All right.